Hi folks, I'm Kelly Coleffer with Fivetran. Welcome in. I'm going to show you today how to build a powerful RAG-based Gen AI application with structured data. The project today is a California wine country visit assistant, which we'll create using the latest tech stack from Fivetran and Snowflake, including Cortex, Arctic, and Streamlit. This demo is from a lab that we ran at Snowflake Summit. Hundreds of people participated and they really enjoyed it. For this RAG app, we're using a custom private data set stored in a structured format in a relational database. The structured data set has over 700 wineries across all of California's diverse wine regions. By the end of the demo, we'll have a functional Cortex AI assistant that can help plan wine country visits, provide detailed information about wineries, even create personalized itineraries. Here's a quick glimpse into that data set using one of my favorite tools, SQL Pro Studio. I'll link it up here for you to check out if you want. As you can see, there are 27 columns and 742 rows representing wineries all across California. It's a decent chunk of the total in California overall. So let's get rolling. Our first step is to set up a data pipeline from the Postgres source database to Snowflake using Fivetran. I've got 581 sources right now out that Fivetran gives me access to. I've also got 8 or 10 sources here bookmarked, things that get asked for a lot: SAP, Workday, Oracle, SQL Server. I'm going to select my Snowflake destination that I have configured and then put in a destination schema prefix. I don't have to create a schema ahead of time in Snowflake. I don't have to manage any of the schema drift associated with any of the changes that happen in this database. Fivetran does that automatically for me. Any DML or DDL changes, Fivetran handles. Some of the other usual suspects you might look for here whenever you're configuring access to a database. And for this Postgres instance, I want access to the industry database. I'm going to select teleport as my change detection mechanism. I have multiple options depending on the database. And I also am going to choose my TLS certificate because that allows Fivetran to encrypt data in motion as it's moving from my source database all the way through to Snowflake here. So Fivetran is going to run the rest of the checks, connect to the database, make sure everything looks good. And once I have finished those checks, then Fivetran is going to let me fetch the source schema associated with that industry database that we just selected. And you can see I've got, 12 schemas out here. I don't want all of those today. Just want I'll take a couple of schemas. We'll take the energy schema and the agriculture schema. I definitely want that California wine country visits table in the agriculture schema. I can block any schemas and tables that I want. Really, that is my call on this data set. We have a lot of customers that take everything in the database, but for this instance, I'm just going to take a couple of schemas. And then from an incremental change standpoint, I want to allow all. If I wanted Fivetran to block new schemas and tables and columns, I could do that as well. Again, this is part of that automated incremental sync that Fivetran provides you. So that's it. We're off to the races. Start that initial sync, I should say. That's in progress. Take, just small data set, take about a minute or so, something like that. While we're waiting on that, take a look at the setup here on incremental. So you can see that sync frequency is defaulted to 6 hours, but I can move that to a minute, 5 minutes, 2 hours, 24 hours, whatever I want, just depending on my downstream data product requirements and how often I want to have that data refreshed. I've got options on table sync mode. The default is soft delete. I've got quite a few things that I can do here as well as it relates to additional security and privacy. You see that little data privacy box pop up if I want to hash at the column level so that I get additional anonymization for any PII columns. I can do that as well. I want to call out Fivetran transformations real quick. Let me select the Snowflake destination that I have here. And I've got, if you look in the upper right, add transformation, I've got 3 transformation options. I've got a quick start data model option. It's got about 52, 53 different quick start data models that are analytics ready to go. I have also got an option if I have my own DBT core project or DBT cloud project, I can use those as well. So a lot of cool features there as it relates to transformations. We're going to get into some transformations here in just a little while. So our data set, the initial sync is complete, a little over 15,000 rows, not a huge data set. Now that Fivetran's moved our data into the Snowflake Data Cloud, let's go take a look at it. There is that new schema that Fivetran created. Remember, you've got 100% schema creation and schema management with Fivetran. There's some of the new columns in that California Wine Country Visits table. Now, it is time to do some transformations. We want to prepare our data for use with the Snowflake Cortex models. So these aren't normal transformations that you might see in a data warehouse. We want to transform the data and make it LLM-friendly or LLM-ready. Just about all data workloads require transformations, and a Gen AI workload is no exception, but the transformations will be different. The script in this first transformation concatenates multiple columns into a single string for each winery. It's really crucial for making our structured data more suitable for the models to create vector representations. So when I run this, I'm going to have 742 rows, each with a single column. That simple concat transformation has essentially created a text document for each row out of the structured data. We'll take a look at that in just a minute. The second script that we're going to run, that uses Snowflake Cortex embed text function to create vector representations for each winery and vineyard. And then these embeddings will allow the models to understand the semantic meaning of the winery data. After running both LLM transformation scripts, let's look at the new table with the concatenated winery information and its corresponding vector embeddings. These transformations, they're key to enabling our retrieval augmented generation approach. It allows Snowflake Cortex models to efficiently search and retrieve relevant information. Ran a select on a single row in the data set. You can see that this simple concat transformation has essentially created a text document for each row out of that structured data. It's made our private enterprise relational structured data very, very usable in an LLM and Gen AI workload. Okay, here's where we are. We've moved a structured data set complete with CDC using Fivetran into the Snowflake Data Cloud. We've run LLM transformations in Snowflake on the new data set to make the data useful to the models we'll be calling within Snowflake Cortex. Now we're ready to build our data application, the California Wine Country Visit Assistant, and we're going to use Streamlit for that. If you haven't tried out Streamlit yet, it's my personal favorite acquisition that Snowflake's made over the past few years. It's now integrated with Snowflake as a native app, making it really easy to use. Streamlit allows you to create interactive data applications directly within the Snowflake environment, meaning our application can access data, it can run queries, it never has to leave the Snowflake ecosystem, and you'll see that today. I gave my new Streamlit app a name, and every time you create a new Streamlit application, you get some, call it Hello World code out of the box. We're not going to use that today, so we'll just delete it, get a clean palette to get us started off here. For the Streamlit application, I have 5 code blocks that I'll add to ultimately build this out completely. I'll briefly walk you through what each code block does. You'll also be able to see the effects of each new code block in the Streamlit data preview when I run the app each time. So code block 1 imports and starts Streamlit. It initializes the setup and session management. And then thirdly, provide some basic UI configuration. You think about things like layout settings, the application title, description of what this application does. The layout's going to use basic Streamlit functions like st-title, caption, and write. When I run it, you'll get a sense for how the app is going to start taking shape. Code block 2 functions include user input management and also some processing and response handling. One of the things that I wanted to call out was the processing simulation. The script actually updates the session state with the user question or prompt and then displays a temporary message indicating the questions being processed. I think we've got the delay set for somewhere around 8, 10, 12 seconds, something like that, but you can update that if you want to. Code block 3 creates a sidebar and allows users to select different AI models with a drop-down. Snowflake Cortex has 10 different models available that use the complete LLM function, and one thing we wanted to do with this app was make all of the models available to try out within the application. Importantly, we also wanted the ability to toggle the use of the custom Fivetran dataset because we wanted to see how the models behaved using our private enterprise data and alternatively simply using the data that they were trained on. We'll take a look at that once we finish building the app. The results are really interesting, so stay tuned. Code block 4 is mostly aesthetics, vertical spacing in the sidebar, tech stack logos, image caption layout, but this code block also initializes conversation history to store and manage the user interaction history in the session. All right, let's take a closer look at code block 5. It's really the heart of the application. Defines a Snowflake interaction logic with Cortex. It's really where the magic happens in our application. It's responsible for, number one, interfacing between Streamlit and Snowflake. Number two, leverages Snowflake Cortex for running the complete function and giving you this interactive conversational approach. And number three, it gives us the ability to implement the RAG approach by combining LLMs with our custom data set. Breaking it down a little bit more, the code starts with a conditional statement that checks whether the user has chosen to use the Fivetran dataset as context. Toggle this back and forth, and it changes how the app processes queries. Depending on whether the dataset is being used or not, the code constructs different SQL queries. If you're using the dataset, the query uses the complete function within Cortex and the new vector table that was created with our private enterprise dataset. If you don't have that toggle checked, it uses a simpler query that directly calls the Cortex complete function with the question and does not use the vector table. The query with the dataset is especially interesting. It uses vector similarity search to find the most relevant winery information based on the user question. It's a key component of a RAG approach. By dynamically constructing queries based on user input and application state, this allows our application to provide intelligent, context-aware responses about California wine country. The integration of vector similarity search with language model completion is a great approach to information retrieval and new content generation. This approach can be adapted to a wide range of enterprise applications for your next Gen AI project. All right, so this is the final app. I'm going to run you through 3 features, and then we'll get to running some prompts here. That's your drop-down for any of the Snowflake Cortex models that are available in AWS US West 2. All those are good. That's where we're running Snowflake for this particular application. Next, this is your toggle to use that new Fivetran data set that we created the vector table from. That's where you toggle it on and off. You're using it, you're not using it. Again, a really interesting feature to take a look at as you're running prompts against the same models. Lastly, the reset conversation button allows you to reset everything that you've done and just start fresh at any time that you want to. All right, let's try out some prompts, see how the various models perform with our data set and without. We'll input some simple prompts, and then we'll do some that are a little more complex. We have a few control records in the Fivetran data set. When I say control records, I mean out of the 742 wineries, there are 5 of them that don't exist anywhere except in that data set. They are not and could never be a part of any model's training data set. This first prompt is using a control record, Coleful Vineyards. I'd love to have a vineyard. I don't, but I do know all about that vineyard and what it offers since I created this record specifically in this data set, and that is very, very accurate. Again, a very simple prompt to get us kicked off. So we use Snowflake Arctic. That's Snowflake's LLM that came out of Snowflake Research. Let's try Reka Flash. Same prompt, didn't have to update anything there, and see how Reka Flash does. Okay, Reka's back. Simple prompt, very different format than what Snowflake Arctic had given us, but again, very, very accurate information. So that looks good. You can actually see we made sure you can tell what models are giving what answers. Same prompt, we'll use Meta's Llama 3 model this time and see how it performs. All right, Llama 3. Yeah, again, very, very accurate information. When we're using the Fivetran dataset as context with that RAG-based approach, we're seeing really good results out of each of the models. All right, I'm going to reset the conversation and not use the Fivetran dataset as context. Let's run that same very simple prompt, tell me about Coleful Vineyards, and see what I get with Snowflake Arctic as well as some of the other models. Okay, here we go. Not using the Fivetran dataset, not using a RAG-based approach. I still got an answer, but I can tell you none of this is accurate. This is completely made up and hallucinated. Okay, that was Arctic. Let's try the same thing with Reka Flash, not using the Fivetran dataset as context. And here's our non-RAG-based approach. This time, Reka's telling me that the family-owned winery is in the Columbia Valley of Washington State. Again, very inaccurate information, absolutely hallucinated. Llama 3 is also inaccurate without RAG. I'll try out one more of the Cortex models using the co-level vineyards control record that's in the data set, but not using the data set as context. This is Mixtral 8x7b. Out of all the models, it's the only one I found against a control record not using the data set, where it flat out admits it wasn't able to find specific information, therefore could not provide an answer. Definitely would encourage you to check out each model for the specific use case that you have. All right, we've taken a look at how RAG works with a very simple prompt. All this has been leading up to testing out the power of the RAG-based approach for new content generation with a much more complex prompt that includes some control records, but also requests information that's not in the Fivetran data set. When I was constructing this prompt, I kept building on it to try and break the models. It's not an example of good prompt engineering, just know that up front. Here's what I ask. Give me a complete visit itinerary that includes 4 to 6 wineries during a 3-day trip. I want to visit Sonoma Coast on day 1, Yountville day 2, Howell Mountain day 3. Organize it into a 3-day trip. Give me hotel recommendations. Give me a catchy name for this trip of no more than 7 words. I'd also like you to provide an estimate for what the trip will cost in the detail on how you estimated the cost. Organize all this information. Give me a nice printable format. And then I even threw in a couple of random requests at the end. What else would you suggest to make this trip better? What types of clothing should I bring if I'm planning my trip for early June? So here's an example of what Rekaflash came back with. You can get an idea. It really did a nice job with, there's the trip name. I did ask for it at the top. But you can get an idea about how these models perform in this RAG-based approach. It did include co-level vineyards and Millman Estate. It also gave me a lot of additional information that I asked for as well, taking information that the model had been trained on originally and combining that with the data set information that we provided in this RAG-based approach. Finish it off here, do the same prompt with Llama 3, and you can get an idea. There's the name, Coast to Mountain Wine Odyssey. I like that. Very nicely formatted, Sonoma Coast, Yountville, Howell Mountain. You see some other activities and recommendations, estimated cost, even clothing recommendations for early June, and some additional suggestions. I'll run this complex prompt one more time using Snowflake Arctic. And while Arctic is running, I have a few learnings that I wanted to share with you. Number one, if you're building a RAG pipeline, data quality is important as always, but you should know your data and know it well. Number two, don't try to turn the models into relational databases. If you have a relational database use case, use a relational database. Models are looking to create something new. Focus on use cases where that is rewarded. Number three, LLM transformations are not data warehouse transformations. You want your transformations to be LLM-friendly and make it easy on the model. So Snowflake Arctic did a nice job as well, pretty much hit on everything that I asked it for in the prompt. Snowflake has done a great job of documenting the Cortex LLM functions, including region availability by function, cost considerations, each model's context window restrictions, and even considerations when choosing a model and what each is tuned for. You've also got descriptions on the functions that we used in this application, which were the complete function and the embed text function, plus a lot of others that you can try out based on your application. I'd encourage you to try out Fivetran and Snowflake together with Cortex and Streamlit with your structured data to build a RAG-based Gen AI application. Fivetran is automated, reliable, and scalable, which allows you to spend your time focused building high-value data products and services, not worrying about data pipelines and data movement. It would be great to hear from you on success you're having with Gen AI and RAG and what you'd like to see profiled next. Take care.